need support on the ones that we're going to talk about, here's what you're going to do instead. There is an assignment that you picked up on the way in titled Quiz Number 2 on Differential Equations. We are not, repeat, not going to take that as a quiz. There is no time for a quiz. With the field trip that we had last Wednesday, there's just no time. That is the best way to study for tomorrow's test. Those are the problems. If you can do those, and if you can do the 2 journal entries that we're going to talk about today, you are set for homework all as well. Yes, ma'am? No, there's one more, because there's one more unit. All right, so let's talk about problem number 2. Where are the friends that are with me on number 2? Okay, friends that are not with me, working on the quiz, working on those questions. All right, number 2. Which graph could be a solution to the differential equation that is shown above? It's not really a differential equation. What is this called again?
Slope field.
It's called the slope field. So if this is the slope field, the question is, which of these 5 is a solution? Now, the connection that I need you to make is that a slope field, right, there's like some differential equation on the side here. They're saying dy dx equals blah. And you would use that differential equation to make the slope field. You could plot points, you could do all sorts of things. Maybe you envision putting this into your calculator. But the reason that you make a slope field, I want to go all the way back to what we did last Wednesday, Thursday, Tuesday, whatever it was. The reason that you make a slope field is the slope field helps you envision what the solution looks like. Everybody still with me on this? We're not solving the differential equation. We're using the slope field to figure out what do my solutions look like. So for example, if I look at this curve over here, this is a familiar looking curve for you guys, exponential. Does this solution curve fit in that slope field? Do you see that solution curve showing up in the slope field? Okay, and some of you are saying, yeah, okay, well let's take a point that we know for sure is on the exponential. It looks like, for example, the point 0, 1 is on there. Let's go to the slope field at 0, 1. That tangent line's telling me my function's increasing. Follow that tangent line. What happens next? I hit this next tangent line, tells me keep increasing. I keep increasing, 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 following those tangent lines. Things seem to match. But if I keep going to the left, I hit this tangent line over here. What's this tangent line telling me to do? It's telling me to decrease. So I keep decreasing. I hit that tangent line. It tells me keep on decreasing. This graph isn't matching this one over here. This can't be the solution. What are the questions on that? Everybody's okay? All right, so does the graph of C show up in this slope field? Are there any points that we know for sure that are on the graph of C? What, like 0, -1 over here?
I was gonna say, where x equals -3, like that whole.
If x equals -3,
But I don't know, like on the graph right there. So like it's going up.
well, if x is equal to -3,
No, but I mean like that whole line.
that whole line, okay. See, here's what I'm thinking. I'm going to take this point over here at 0, -1, and I'm going to find it in the slope field. There it is in the slope field. What does that tangent line tell me to do? It tells me to decrease. So I decrease, and I hit this next tangent line, which says keep decreasing. But as I start following that, I hit these other tangent lines that are pushing me back up. If I follow the tangent lines to the left, those tangent lines are going to be pushing me back down. This graph, I did say C was the answer, right?
Yes.
Okay. This graph matches what I would get out of the slope field, whereas all these other ones are going to fail to match for whatever different reasons. But the key was pick a point that you know for sure, imagine like your initial condition, find it in the slope field, and trace along those tangent lines to see if you're getting the same graph. Done, that's it. All right, where are the friends that want to talk about number 3? Okay, that looks like nobody, so we're not going to talk about number 3. Friends that want to talk about number 4. I see Daisy, I see Margia, I see some friends from number 4. All right, number 4. Number 4, what do we got? The acceleration of a particle moving on the x-axis at time greater than 0. A of t is equal to 1 over t squared. Okay? So I've got a of t is 1 over t squared. When t is equal to 1 second, the position of the particle is x equals 2, and it's moving with a velocity v equals -1. The position when t equals e seconds is what? So when t is equal to e, what's the position? So for the friends who got this wrong, what do we try? Jasmine, what did you try?
I did the antiderivative
Why?
because it acts for position.
Because what?
It acts for position when t equals t.
Okay, they're asking me for position, but they've given me acceleration. What's the connection between acceleration and position?
Now we go to the velocity and the position.
Right, you start at position, you take a derivative, you get to velocity, you take another derivative, you get to acceleration. So they've given me acceleration. My first stop then is going to have to be velocity. What's the integral of 1 over t squared? Right, I'd probably rewrite this as t to the -2 dt. Antiderivative, I'm going to add 1 to the power, divide by the new power, plus the constant. So my velocity is -1 t to the -1 plus c. That's your velocity. It would be nice if we could figure out what Charlie is. And they gave me an initial condition. They said at time 1, the velocity is going to be -1. So I can plug it in from there, figure out Charlie. Once you've done that, find the antiderivative again to get to the position. So I'm going to stop if that's okay. All right, are all the friends okay? Anthony, do you have any questions that we need to talk about? Abraham, you doing okay? All right. It's so quiet with that one here in Laura. All right, so here's the plan. I want to go over with you guys what I would call the hardest differential equation problem that the College Board has come out with so far. So this is this first one. It says source 2015. What's going to happen when you guys take your AP exam on Thursday, May 5th, you're going to take the exam. I'm not going to see you that morning. I'm not allowed to see you that morning other than to say, enjoy the ride, give you some donuts, and that's about it. You're going to go into a room. You're going to spend 4 hours taking the test. All the work that we've done is going to boil down to that 4-hour block of time. You're going to come out leaking brain fluid. You will probably want to talk to me about the exam. And I will say, no, we cannot talk about the exam. We cannot talk about the exam until 48 hours has gone by. At that point, the College Board releases the free response, and I get to look at the free response questions and feel like I did a really good job preparing you guys for excellence. Last year, this question caught all the AP Calculus teachers by surprise. We started calling one another, like, what's going on? This is not the kind of question we prepared the kids for. What's gonna happen? The poor babies, they don't know what to do. And it was just a bloodbath. It was worth 9 points. All the free response questions are worth 9 points. There's 6 free response questions on the exam, each worth 9 points. The average for the AB students was 2.6 points. For the BC students, it was 4.2 points. And before you get confused and say that I'm talking about yes prep students, no, I mean In the world. In the world of all 500,000 plus students who took the AP exam last year, the average on this question was 2.6 little points. For the BC kiddos, 4.2 points. This question was a bloodbath. Bloodbath. I want to give you guys 5 minutes, working with your partners, see what you can do. Go as far as you can. Know that this is hard, and it is okay. There will be no crying in the next 5 minutes. I'll set the timer. We can start crying after that.
You guys know
Was supposed to be anything? No.
what was in like
No, we already saw it was in the thing.
Like it. Like it. Like it. Like it. 2 points already. Christian's on the board with 2 points. Like it. Like it. Like it. Like it. Like it. Like it. Jose's on the board with 2 points already. Not even 5 minutes in. Like it. Like it, like it, like it, like it, like it. 2 points. The world average is 2.6 points. There's already 4 people in the room sitting on top of 2 points. Like it, 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 like it. Keep going. Which one did we do? Okay, here we go. How did you get that? 2 times 0 minus 2 is 1. Like it, like it, like it, like it, like it. As soon as you get that one correct, you get 2 points out of 2. Keep going. Love it. 2 points. You were like 1 little point away from Like it, like it, like it, like it. 2 points. The world average is 2.6 points. Daisy just picked up 2 points. And so did Eunice. And so did David. And hold on, it's Anthony's turn. And so did Anthony, what do you want? 1, 2, 3, 4. Counterclockwise. Like it, like it. I think I've already come over here. Okay. Life is good. No.
Is this sorry?
2 points.
Okay.
You're at 2
That's
points.
like
Yes.
it's sorry.
These are negative numbers. Did you get 2 minus y dydx?
Thanks, sir.
I don't know what I'm doing.
Nice. 3 points. Jonathan is above average. Just a little bit though. All right. So, all goes well. Part A worth 2 points if your slope field looks like this. Horizontal tangent line, increasing, increasing faster, increasing, decreasing, decreasing. When I read this, 1 point for tangent lines when x equals 0. If you have all 3 of these correct, give yourself a point. If you have all 3 of these correct, give yourself a second point. How many guys just picked up 2 points? Slope fields are easy. Slope fields are your friend. We hope and pray and sacrifice small chickens every year that there will be a slope fields question on the test. And then we get to part B.
That's
Here we go. Find d squared y dx squared in terms of x and y. What exactly did they just tell you to do?
Find the second derivative.
Go find the second derivative, please, if you haven't done so already. dy dx, is it 2x minus y?
Yes.
All right. So I heard d squared y dx squared means you guys want to find the derivative of the first derivative. And they want it in terms of x and y. Well, that means take the derivative of 2x minus y. Derivative of 2x, everybody knows is 2 minus the derivative of y, everybody knows is
dy over dx.
uh-oh.
dy dx.
The derivative of
dy over
y
dx.
is
dy over dx.
dy dx. Not 1. You're taking the derivative with respect to x. Now don't stop here. Jennifer, why are we not going to stop here? Either of the Jennifers.
Because they want it in terms of x and y.
We want the answer in terms of x and y, not the answer in terms of dy dx. So I've got to get that dy dx out of there and do what? What am I going to do with that? I'm going to take the fact that dy dx equals 2x minus y and just say, there it is. Simplify. If you want to, 2 minus 2x plus y, getting there gets your third point. Jonathan had a third point. Did anybody else honestly get there? Third point, third point, third point, third point. All right, not done. Determine the concavity of all solution curves for the differential equation in quadrant 2. I want to determine the concavity of all the solution curves in quadrant 2. Have a quick conversation with somebody near you. What are your thoughts right now?
Yeah, that now, like, is there no point? It's on the border between 1 and 2. It might be. It might be, honestly. That'd be too easy.
All right, some brave soul, tell me, what do you know? What's the idea here? Quadrant 2. Why are they having you focus on quadrant 2? Anthony, why are they having us focus on quadrant 2?
We're going to be plugging in negative x values and positive y.
Okay, if you don't remember, here's quadrant 1, here's quadrant number 2, quadrant number 3, quadrant number 4. If I'm in quadrant number 2, the thing that you just said, Anthony, one more time?
Negative x values.
The x values are negative and the y values?
I said it.
The y values are going to be positive. So what does that tell you about your second derivative? If it's 2 minus 2 times x plus y, if I'm in quadrant 2, my x values are all negative, my y values are all positive, so the second derivative, David? Oh, I didn't realize. You're just stretching those 18-year-old arms. Second derivative is 2 minus 2 times x plus y. If you're in quadrant 2, what do you know?
It's gonna be positive.
Why?
Because the 2 minus the negative is gonna be plus, so it's positive.
Right, the x value is negative, so negative 2 times that has to be a positive number. I've got 2, I'm adding a positive number, and then the y? Also positive, so my second derivative is positive. Now don't blow it. Answer their question. Answer their question. What's their question?
Determine the concavity.
Determine the concavity. What's the concavity? Therefore, the solution curves are all concave up in quadrant 2. Perfect. This is not the kind of conversation we were having last year, or the year before, or the year before that. You need to be able to take the information that they've given to you and push a little bit further. Okay? So with that, take a minute to see what you can do with part C. Part C is worth 2 points. I'm really curious to see what you guys can do. I'm seeing it happen in all the different parts of the room. All these students are trying to do separation of variables. There is nothing in part C that says anything about separation of variables. But I understand you get like itchy trigger finger. We're doing a differential equations question. One of the skills I'm really good at that is always worth a lot of points is separation of variables. I know, separate the variables. Integrate both sides. Solve for y. Use the initial condition. Points rain down from the sky. But that's not what this question's asking. This question, let y equal f of x be the particular solution to the differential equation with initial condition. I bet it's this initial condition that made everybody jump off the diving board at the same time. Does f have a relative minimum, a relative maximum, or neither? That's the question. Somebody tell me, stop what you're doing, stop separating the variables. What does it mean for a function to have a relative minimum? What does that look like? What do you know about the derivative? Oh my gosh, it must be, it's Monday. It's Monday. Can you guys show me a relative minimum for a second? Relative minimum, there should be two things that we're trying to do right now. There's this kind, and then the other thing? A cusp point, right? So if you have a relative minimum, You have the smooth kind or you have the cusp point. A relative maximum is going to look like that, or it's going to look like that. Has to be one of those two. Look at your derivative. Your derivative is, what was it, 2x minus y? If I have one of these cusp points, what do we know about the derivative?
And
If I have one of these cusp points, the thing that you know for sure,
derivative.
derivative does not exist. In this case over here, dy dx does not exist. If you look at this guy here, dy dx equals 2x minus y, this is always going to exist. There's no dividing by 0. There's no strange stuff that's happening here. It's just, there it is. So I can't have one of these two cases. I either have the rounded minimum, or I have the rounded maximum, or I have neither. Somebody tell me, if you have this rounded minimum, what do you know about the derivative? What has to be true? One person. About the derivative. What has to be true, one, about the derivative? Okay, the derivative here would be equal to 0, and what's happening before and after?
Decreasing and increasing.
Right, we're decreasing to increasing. That means
Negative to
derivative goes from negative to positive. In this rounded max, your derivative is equal to 0, and over here we're increasing, over here we're decreasing. The question's really going to boil down to what's happening with the derivative. And if I check the derivative, if I find dy dx at that initial condition, 2 comma 3, is it 2 times 2 minus 3, I'm going to get 1. Is that a minimum?
No.
Is it a minimum? If I have a minimum, then the derivative has to be 0. Is it a maximum? If it was a maximum, the derivative would have to be 0. So the conclusion? Right. Therefore, y equals f of x has neither a max, nor a min at 2 comma 3. Because if it had a max, then I would expect that the derivative would be equal to 0, and we'd see this increasing to decreasing behavior. If it was a minimum, the derivative would be equal to 0, and we'd see this decreasing to increasing behavior. And neither one of those things happens. Okay. So here's what I want to do. I think for 80% of you guys in the room right now, we have gone as far with this problem as I wanted to. I was really pleased to see how well parts A and part B went. Part C was a butt whooping. Not a surprise. We are not going to have conversation about part D unless you are really interested in pushing in a whole new direction. That might be just 5 or 6 of you that want to have a conversation with me about part D. Where are those folks? You want to push. You're hungry for something a little bit more. Giselle, thank you for joining, and Marvin's going to join. I think Christian's going to join as well, and I'm pretty sure Adriana and Kimberly are going to join as well. The 5 of you are going to join over here in these front 2 tables. Everybody else, you're going to go to the back, and I want you to work on an application problem, one that I know you are ready for and should be expecting. But for the friends that just pointed out, you're up front. Everybody else, you're going to the back. Come on, Marvin. All right. Friends up front, we're going to talk in a little bit. Friends in the back, once we're done rubbing each other's heads, I want you guys to focus on the other journal entry. It's called run by Roberto Martinez at North Central. Okay. Parts A, B, C, and D should all make you feel very, very good. This is the level I would expect you to be able to perform at tomorrow
There are no surprises, there are no curveballs, just show me what you can do. Enjoy the ride. We'll talk in a little bit. Friends up front. Thank you for being the friends up front. All right. So are there any thoughts or questions on part B or part C? Anything that wasn't clear, anything we want to talk about? Okay. Part D is not the kind of thing I'm going to hold you accountable for tomorrow, but knowing the smarticle particles that exist within your 5 brains, or therefore, and then, kind of you, okay? Then I really want to just have some conversation about part D and see what we can do, okay? So take a moment, read over part D, and we'll talk. And if it helps at all, part D is worth 3 points. I was only able to earn 2 of them. I was very disappointed in myself. I like to earn all the points. All right, find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. They're still not asking you to solve the differential equation. They want you to show that that is a solution to dy dx equals 2x minus y. So what ideas are out there? Giselle, what are your thoughts?
Well, we know that m basically means slope, and we know that the derivative gives you the slope.
Okay. So definitely m means slope of a line. Here we are talking about the derivative. Sure. They're saying find the values of the constants m and b for which this guy here is a solution to the differential equation. What does it even mean? If a function or a curve is a solution to a differential equation. We've dabbled with this before. If this is a solution to the differential equation, then it means that you can plug it in and get something that is true. Right? So this says y equals mx plus b. This guy over here says, but wait, dy dx equals 2x minus y. So, this is like the recipe for your differential equation. This says the derivative is equal to 2 times the x value minus the y value. Well, what's the derivative? If I go over here and I find the derivative, you guys will tell me the derivative is?
M.
Derivative is m, right? According to this differential equation, your derivative, m, is equal to 2 times x minus the y value, and the y value is mx plus b. Right, we're using the idea that this is the solution, meaning I can plug that into my differential equation, and I should get something that makes sense. Over here, I took the derivative on both sides. Over here, I'm just plugging this and the original solution into the differential equation to see what I can get. The goal is to figure out what are the right values for m and b. And to be honest, this is where I got stuck. This is where I stopped being successful. What I know is this: if you found the derivative, you got a point. If you set up that differential equation, you got a second point. When I was reading through the comments from the College Board, very few students were earning any points here at all. And almost nobody earned the next point. The goal is to solve this equation for m and for b. And I think this is something that you guys just probably have never ever done before. And so let me just show you what we do here. We're going to say m equals 2x minus mx plus b. And what we're going to do, it's called compare the coefficients. I at least wanted you guys to see this one time. What you do is you look at the constants.
and you say, let's look at the constants on the left side of the equation and the constants on the right side of the equation. If this is going to be true, if this equation in terms of x is going to be true, then the constant on the left has to equal the constant on the right, that the m and the b are going to have to be equal to each other. And then what you do is you look at the linear coefficients. So we've got constants, you've got the linear coefficients. I'm going to look at the coefficients of anything that's like x to the first power. On the left-hand side, there is nothing. On the right-hand side, well, what's equal to, what are the coefficients of the linear terms? We've got the 2x and the minus x, so it's going to be 2 minus m. 0 equals 2 minus m. Out of that one equation, the idea with this compare the coefficients is you say, all right, if this is always true, the constants have to be the same, and the linear coefficients have to be the same. Out of this one equation, you get 2. You guys should be able to figure out from here what m and b are. Which one? If I look at the linear coefficients, it says that 0 equals 2 minus m, so that must mean that m's equal to 2. And if m's equal to 2,
Then b's equal to 2.
then b is equal to 2. There's really not much in this part of the problem that is anything like anything we've talked about at all. And like across the world, most calculus students have no idea what to do in part D. But part A felt good for the 5 of you. Part B felt pretty good. There was some promise and some potential there. Okay, good. Here's not what you guys do. I think at this point, we're just going to put a pin in this. Let's not worry about that part of it. I care greatly about A, B, and C. If you want to feel good about yourself, I would recommend you work in this other journal entry, which is going to be much more in line with what you're going to see in tomorrow's test and what I would expect to see on the AP. Nora, I thought you were absent today,
Yeah.
but you made it for my class.
I try to make it beforehand, so stuff
I appreciate you making it here. Do you want? Why don't you take a minute to check your homework? Mine.
Do you need me to stop recording so I can hear you?
Yeah, we can stop recording. Okay.